been practicing all morning, thinking about getting my colors. So. All right, preliminaries. We will get our x-intercepts, y-intercepts. Of course, y-intercept is the easiest. Then your x-intercept, plugging in 0. For y, and solving this. Now, sine x, if you think of your unit circle, there are lots of places on your unit circle where your y-coordinate is equal to 0, right? So we've got 0 and pi and 2 pi and 3 pi. Technically, if we wanted to write all of the solutions, just a little reminder of how we wrote this. If we wanted to write 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, all of them, we could write that as k pi, where k is an integer. For us, because our domain is just between 0 and 2 pi, we're only going to have to worry about 0, pi, and 2 pi. So our x-intercepts are at 0, 0, which is the same as our y-intercept, pi, comma, 0, and 2 pi, comma, 0. Again, you don't need to write this down. But you do need to look at your equation and say, are there any non-permissible values? Would this equation have any asymptotes? And one thing to think about as far as the limit as x goes to infinity or as x goes to negative infinity, you know your sine graph oscillates. It goes between 1 and negative 1, 1 and negative 1. So it's not getting bigger or smaller, it's not approaching 0. And the x in front would just be getting bigger and bigger and bigger. So there's going to be no horizontal asymptotes in this case. Next we go to our derivatives. First derivative. There we go. Notation are we using? Y equals y prime. We're going to have to use our product rule. So keep one the same, multiply by the derivative of the second one, then keep the second one the same, multiply by the derivative of the first one. You're sitting there. You're the sign to me. And this one was listed as a calculator because at this point, we get the following, that x sine x, x cos x plus sine x is equal to 0. And any kind of algebra that we decide to try to do to solve this is going to result in not being able to solve it. We're going to get an equation where we have trig functions and an x. They're difficult to solve. There are algebraic techniques that we could use, but for this one, we are going to go to Desmos and have a look. Now, all things saying is if you had to use a graphing calculator in a question like this to graph, then it probably makes the most sense just to graph it from, if they're like, graph this, and you're allowed to use a graphing calculator, then it would make most sense to go to a program to use that right away. So two things I'm going to do here. One is, if you were allowed to use a graphing calculator right for the beginning from this one, then it would make sense and 0 to 2 pi would go up to this point. So how hard is it to get all of those points. The only thing that is not labeled when you click on it in Desmos are the inflection points. And there's probably a really easy way to do that. I'd probably just have to Google it. But we don't have that right now. But we have on the regular graph all the maxes and mins. Now, if we add another graph here, which was we can find out that our derivative is equal to 0 at 0, 2.029, and 4.913. So going back to our equation, I think the only one you could probably do mental math-wise is figure out the 0. Because this would be 0, and sine of 0 is 0, but the other one's not so easy. So we've got x equals 0, 2.029, and 4.913. And I'm going to add onto our number line here 2 pi, because the question asked us only to graph it between 0 and 2 pi. So we do not have to worry about these sections for increasing and decreasing, because we are only going to graph it between 0 and 2 pi. Now, if you plug in something between 0 and 2.029 into your derivative, again, we have a lot of choices of values. I would probably choose something from my pi plate that I could know and do quickly. Okay? In this case, I would probably choose for this first section pi over 2. Pi divided by 2 is about 1.57. And if I plug that in, cos of pi over 2 is 0. Sine of pi over 2 is 1. This section will be positive and increasing. Between 2.029 and 4.913, I'd probably choose pi. Okay? Cos of pi is -1. Sine of pi is 0. -1 times pi will be negative. This section is decreasing. And between 4.913 and 2 pi, I'd probably choose 3 pi over 2. And choosing 3 pi over 2, again, will make sine equal to -1. Cos equal to 0. So did I get -1 again? Just doing, okay. If I choose 3 pi over 2, I'm actually still in this section. The 6.28, which is 2 pi, minus pi over 2, 1.57, would still leave me in this section. So I would probably have to choose something closer to 2 pi. Again, you have a calculator on this one. So we're trying to do it with mental math, but you would have access to this already. What do we know when we plug in something? This is the graph of our derivative. When we plug in something bigger than 4.93, you're going to get a positive value. You can see that from your graph. But just following the steps, a little bit of both, using your calculator to cheat a little bit, and using the steps just to see what it would look like, we can get all of our information that way. Okay, so we know that 2.029, comma something, and 4.913, comma something. This one is a max. This one is a minimum. if we go back to our Desmos graph, steal the values from there, we got 1.82 and negative 4.814. And now we can go to our second derivative. And our second derivative, we will need to use our, we're going to need to use our calculator, but there are values here that we won't be able to get otherwise. So, our second derivative. Y prime, we're going to have to use our product rule first. Keep the first one the same, derivative of cos, negative sine x, then keep cos the same. Derivative of 1 is 1, plus then the derivative of sine. So again, what I did for the second derivative is I took my first derivative, I had to do a product rule for this part. So that part ended up being that section right there. And then I just had to do the derivative of sine afterwards, which became cos. So again, our second derivative, not something that would be easy to solve. So we'd have to use our graphing calculator, Desmos. I'm going to type it into Desmos again. Is it sine x or cos x? It's sine x. I'm going to check. Negative x sine x plus 2 cos x. Negative x sine x. There it is. Okay. So on here, what's going to be important are where it's equal to 0, which is at 1.077 and 3.644. So we would have set this equal to So we've got 1.077 and 3.644. We would have to plug those in to our original equation here and find out where they are equal. Now this is where I'm not as familiar with Desmos, but I would probably type and there would be my final graph from 0 to 2 pi. If I was going to steal this so that, I'll write these numbers down, 9.948 Those are our inflection points. So if the question was asking you to graph it completely from 0 to 2 pi, which means labeling all x-intercepts, all y-intercepts, all maximums and minimums, and inflection points, then you would have to go to Desmos, and get that graph. Hopefully, your test allows you the little picture button where you can just take a picture of it and put it into your notes. But this is what your final graph would look like. And you would have all of your x-intercepts labeled, your maximum and your minimum labeled, as well as your inflection points labeled. And so we still needed, even though we had Desmos, we still needed our calculus to find those inflection points so far, okay? Your homework is for you to find out, how does Desmos find an inflection point? And bring that to class on Monday so that we can figure out the shortcut. I promise I won't look it up. I'm terribly curious right now. But I'm going to leave it to you. You have to teach me something. So your job is to find out the better way to find our inflection point.